Hello guys, welcome to our video. Today's video is going to be about processes. As we all know that process is a very long topic, so we're gonna divide that topic into 3 or 4 videos. Okay, in this video I'm gonna basically cover everything about what is process, the architecture and PCB. Okay, PCB is process control block. We'll go into it. So starting off, what is process? If you look at it, you might have heard that everything inside of your operating system or everything in your system which runs is a process. If I show you my task manager, if you can see, these are all the processes. So the app you run, okay, so all the background processes and everything, it is showing over here. So each and every program is a process. I'll explain you how. Okay, imagine there is a program, okay, and this program, okay, this program is inside your disk. Disk is simply, it can be SSD or it can be SSD, wherever. So it is basically this program or your app, whatever you say, is stored on your disk. And if this program needs to be run, like if you want to open it, when you double click it, what happens is this process, it comes into your RAM. Okay, so this, this thing is known as process. So you can define it as a program under execution. Okay, it is known as process. Okay, which is the simplest definition you can find. You might be wondering, why do we need processes? So each and every program which it needs to be run, it needs to go to the RAM and then it executes. So without the process, your program, you might not be able to see your program live, or you might not be able to see your app, or you can't do anything in your system. Okay, moving on, we'll see how the architecture of the process looks like. So it looks something like this. So if we focus on it, we'll start with what is text. Text is simply a code. Okay, so when you write a program, it must have a multiple line of code, like int a, then your functions, okay, then everything. So this is a code. So a process, when it is converted from a program to a process, it consists of text and it consists of some data, and this data is global and it is fixed. Okay, data like if you need to use a variable which you need to use again and again in your program, so it is all saved over here. Then comes something known as stack. We all know what is the purpose of stack. Okay, stack is basically a LIFO structure. And when do we need the LIFO structure? When we like suppose you take an example of a function 1, inside it there is a function 2, inside it there is a function 3. Okay, now if we look at this function 1, function 2, function 3 is what, it is something known as recursion. So when function 1 is called, function 1 basically it waits and it goes to function 2. When you go inside function 2, function 3, so something like, there is a recursion thing going on. So to when the function it returns, it makes sure, the stack makes sure that it returns in the backward format. So let's say it stores something like function 1, function 2, function 3. So whenever there is a return value, you write the function with a return value. So whenever there is a return value, the stack makes sure that this function is executed first. When this comes out, this is executed, this comes out, this is executed, and this way the program which is, it runs quite smoothly. Okay, so stack, it stores basically function arguments or all things about function. Okay, now heap, this is an important part. So let me make some space over here. Okay, heap. So what is heap? heap, it is something known as a memory. Let's say when you want to run a program, okay, so you don't have a memory, what you will do? For a temporary period of time, you will assign your program a memory, okay. So this memory will store user input. Let's say if there is a user, there is something asked by the user, like there is a question like your age. So initially you can't, you don't have the memory, so what you will do is you will store that variable or store that value inside of this memory. And as you move forward, this memory, when no longer you need it, when this, the age, when you no longer need it, you need to free it as well. Otherwise this heap will grow, and it will, your process will run out of memory and you will not be able to store some other important data. Okay, so this is how the architecture of process looks like. So moving forward, we'll talk about PCB. So what is PCB? PCB, if we define it as a process control block, it stores all the relevant information of a process that we need. So it stores, if we look at it, what it stores is, it stores a PID. PID is a process number. Let's say currently one process is running, then second, third, so serial number, it is same known as PID. Okay, then it stores a state. So process state, there are multiple states of processes. We're gonna talk about it in the next video. So these states are something, if the process is running, if the process is new, if the process is finished, or whatever the state it is, it stores that. Now it also stores something as priority. Priority is a number. Let's say you have P1 process, you have P2 process, you have P3 process, and here are your priority. Okay, so P1 process has priority of 2, this has a priority of 1, this has a priority of 3. So whenever the OS, it starts running the processes, it checks which process has the highest number of priority. It sees that P3 has it, so P3 it runs first, and P1 and P2, they are on the wait state. Okay, we're gonna talk about this more, like how our priority is done and whatever happens, but yeah, it stores something known as priority. Now it also stores something known as registers. Now what are these registers? Okay, so let's say your program or your process, let's say, we're not gonna talk about program, but to make it simple, we'll talk about your process. Okay, there is a code written. Okay, there is something, there is something, there is something, there is something. Now let's say your process is running and you have suddenly it stops, or suddenly it goes for something, a keyboard input or something, it is waiting for something. So wherever it stopped, let's say it stopped at this point and something at this point, so who keeps a track of this one, like where it is stopped? It is, so registers keeps a track of the instruction at which the process stopped and gone, and it was gone for the input. Whenever the process is resumed, it resumes back on this, so it comes to PCB again, it asks for registers, and this way it is gone. We're gonna talk about this in detail. I'm just giving you a brief, like how does it look like. And it stores something known as list of open files and devices, and open files and devices are basically nothing but they are all the devices, like let's say there is you have a mouse, you have a keyboard, and you have a camera and everything. So the process, like let's say this P1, it is running, it is doing something with mouse, it is doing something with keyboard, it is doing something with camera. The PCB will store the information of all this, that it is running on this, like these devices are being run under this. Then open files are the files which processes are using. Let's say if it's a Chrome, then it is using Chrome. Let's say if you are downloading something, it will store that as well, that this process is downloading something. Okay, so this was all about a brief of what we discussed today. Okay, what is process, what is the architecture, and what is PCB and all. Okay, We're gonna talk about more in detail about all the stuff we discussed today in the next video. So yeah, thank you for watching.